So hello everyone, welcome to this new session. So in this session we are going to discuss we are going to continue with module 5 only, and we are going to discuss one more concept which is related to uniform plane wave. Okay, that is the movement of electric field intensity and magnetic field intensity is uniformly distributed along the surface. Okay, what is the relationship between them when they are moving in a uniform field or uniform plane wave? Okay, so first thing is first the definition of uniform plane wave. Uniform plane wave is defined as in these 4 points, that is, first point is electric field intensity and magnetic field intensity are uniform in nature with respect to uniform plane wave. Second point is that E and H are perpendicular to each other. Third point is that E and H are in one single plane. Okay, both the electric field and magnetic field are induced in a single plane. Okay, in that single plane its condition is that it needs to be uniform in nature. Okay, and this E and H are perpendicular to the direction of propagation. Okay, in this figure you can see these are the directions of propagations here, which this indicating arrow. These are the directions of propagations. Okay, so now let's see what is this concept of uniform plane wave. So let E be in y direction and H be in z direction. Okay, that is electric field and magnetic field, let it be in y and z direction respectively. Okay, and let X be in the direction of propagation. Okay, so this is the direction of propagation here, X. So E is equal to, in generally, Ex Ax plus Ey Ay plus Ez Az. Same goes for H. Okay, so now a uniform plane wave, that is UPW in free space. For free space we have some conditions, that is mu is equal to mu naught, epsilon is equal to epsilon naught, and sigma equal to 0. As same goes with Jc is equal to sigma times C is equal to 0. Okay, the conduction current density, conductivity and permittivity would be in free space, that is mu naught and epsilon naught. So now let's consider the Maxwell's equation, that is del cross E is equal to minus dou B by dou T. So this relation which we have got from Faraday's law, consider that equation, and here in this case B is equal to mu times H, but in free space mu equal to mu naught, so that's why minus mu naught dou H by dou T, since B is equal to mu naught H. Okay, so now this del cross E, substitute it, take the determinant, that is Ax, Ay, Az, dou by dou X, dou by dou Y, dou by dou Z, 0, Ey, 0. Okay, since we are considering UPW with E in y direction and H in z direction. Okay, since we have considered this E in y direction here, so that's why, since we have a del cross E, so that's why the y component would only be activated, the rest of the two components would be 0, so that's why these two are 0. That's equal to mu naught dou by dou T of Hz. Okay, because I have taken H in z direction, right? So that's why this H would be replaced by Hz into Az vector. These two components would be neglected, only this component would be left out. Okay, and X is the direction of propagation, so that's why Ex equal to Ez equal to 0, Hx equal to Hy equal to 0. Okay, because we have taken E in y direction and H in z direction, so that's why the rest of the two components are equal to 0. Okay, so now after taking its determinant, so this is the expression which you are getting, that is dou by dou X of Ey into Az vector is equal to minus mu naught dou by dou T of Hz into Az vector. Az vector you can cancel it out from both sides, so the remaining term is dou by dou X of Ey is equal to minus mu naught dou by dou T of Hz. Okay, so whatever this equation you got, you name it as equation 1. So this is the plane wave equation which we have obtained when we take the electric field and magnetic field in a direction along with the direction of propagation in a particular direction, that is y. In this case the electric field is in y direction and magnetic field is in z direction, so that's why if we see the relationship between them using the Maxwell's equation for uniform plane wave in free space, so this is the equation which we obtain. Okay, so that's why you can name it as equation 1, because this is further many more steps are there for this, but for in case of only for uniform plane wave propagation, okay, if they ask, this much is enough to write from here till here, this one full page is enough. Okay, if they ask for 10 marks or something, still more further derivation is there, so that's why I have named it as equation 1. So now next what would be happening, let's see that now. So this is a continuation of the derivation only, just a different heading, that is Maxwell's equation from Ampere's law. Maxwell's equation from Ampere's law. Okay, so we have derived one Maxwell's equation from Ampere's law, that is del cross H is equal to Jc plus Jd, right, where this Jc is the conduction current density and JD is the displacement current density, that is again equal to epsilon times dou E by dou T. Okay, since JC is equal to sigma times E, but for sigma times E, but for in free space we have considered this sigma equal to 0, right? So that's why this whole term would be equal to 0. We are left with only this term, that is epsilon naught dou E by dou T. So this is not equal to 0 because we have one term that is dou by dou T of with respect to electric field, so we cannot make this term equal to 0. Okay, so now in last case we have considered Maxwell's equation for electric field. Same in this case we are considering Maxwell's equation from Ampere's law in magnetic field, and take the determinant of that Ax, Ay, Az, dou by dou x, dou by dou y, dou by dou z, and this would be equal to 0 because we have taken the magnetic field in z direction, so that's why we are getting only Hz. Same goes with the right hand side, epsilon times epsilon naught dou by dou T of Ey. E is equal to Ey here because we have taken this E in y direction, so that's why Ey a cap y. So again same thing, take the determinant. So this is the term which you obtain after taking the determinant, that is minus dou by dou y of Hz Ay vector is equal to minus epsilon naught dou by dou T of Ay vector. So this Ay vector and Ay vector gets cancelled, so remaining term, this minus and minus also gets cancelled. So here this is plus. Okay, so that's why dou Hz by dou y is equal to epsilon naught dou by dou T of Ey. Okay, so this equation we have got from Maxwell's equation from Ampere's law, but similarly for equation 1 we have got from Maxwell's equation in with respect to free space in by using Faraday's law. Okay, so name those equations as equation 1, this as equation 1 and equation 2. Then differentiate equation 1 with respect to x and equation 2 with respect to t. Okay, what we would be getting if we differentiate equation 1 with respect to x, we would be getting dou square Ey by dou x square is equal to minus mu naught dou by dou x of dou by dou T of Hz. Okay, that is 1 by mu naught. I am taking this mu naught to other side, that is minus 1 by mu naught of dou square Ey by dou x square is equal to dou by dou x of dou by dou T of Hz. So now name this as equation 3. Okay, so now what we are doing is dou by dou T of dou by dou x of Hz is equal to minus epsilon naught dou square Ey by dou T square. Okay, I am replacing this. So for this equation, as we have got it from equation 2, where we are differentiating it with respect to t. Okay, so when we differentiate this equation with respect to t, so this is the equation which we obtained. Okay, and when we differentiate equation 1 with respect to x, this is the equation which we obtained. So now what we can see is RHS of equation 3 and LHS of equation 4 are same. Okay, so therefore LHS of 3 and RHS of 4 are equal. Since the RHS and LHS of equation 3 and 4 are same, that is dou by dou x into dou by dou T of Hz is equal to dou by dou T into dou by dou x of Hz. These two are interrelated, that's it. But so what we can do is we can equate the other two terms. Okay, that is minus 1 by mu naught into dou square Ey by dou x square is equal to minus epsilon naught dou square Ey by dou T square, where this minus and minus would be getting cancelled. So therefore 1 by mu naught of dou square Ey by dou x square is equal to epsilon naught dou square Ey by dou T square. So therefore dou square Ey by dou T square is equal to 1 by mu naught into epsilon naught. I am bringing here mu naught into epsilon naught divided by dou square Ey by dou x square. So now this equation which you have got here, so this is wave equation in terms of electric field. Okay, so this is the wave equation here which we have got in terms of electric field. Similarly, we can derive the wave equation in terms of magnetic field, okay, by interchanging few of the terms. That is, what we can do is, so if we check this equation whatever we got dimensionally, that is dou square Ey by dou T square is equal to 1 by mu naught epsilon naught dou square Ey by dou x square. Okay, so we know that Ey, that is electric field. Okay, let's take its SI unit, that is volts per meter, right? That I have written here V by M divided by T square. Okay, that is times square, and SI unit of time is second, so this we are taking it as second square. Same thing here, that is 1 by mu naught epsilon naught, keep it as it is. Again Ey, that is volts per meter divided by x square. Okay, x represents the distance, right? Distance or displacement. Its unit is meter, and here we should be writing it as meter square. Okay, that is 1 by s square. So here we can cancel v by m from both sides. 1 by s square is equal to 1 by mu naught epsilon naught divided by 1 by meter square. So bring this meter square to other side. So meter square by s square is equal to 1 by mu naught epsilon naught. So we know that meter per second. What is meter per second? Velocity, right? That is the velocity. So that's why m square by s square is equal to v square. V square is equal to 1 by mu naught epsilon naught. So therefore v is equal to 1 by square root of mu naught epsilon naught. If is where mu naught and epsilon naught, I've told you, right? Permittivity in free space and permeability in free space, it has fixed values. So if we substitute that values, and if we check the dimensionally the equation of the wave equation, that is what we are getting is the standard value of velocity of light, which you might be knowing, that is 3 into 10 to the power 8 meter per second. Okay, if we substitute the value of mu naught epsilon naught, if you want you can check it, substitute the values of mu naught and epsilon naught in this equation, and this is the answer we are getting, 3 into 10 power 8 meter per second. So therefore we can say that uniform plane wave travels with the velocity of light. Okay, so this dimensional conclusion why I have done, because in order to conclude this statement, that is uniform plane wave travels with the velocity of light. Similarly, what we can do is replace Ey by Hz, that is in place of magnetic field, that is dou square Hz by dou t square is equal to v square dou square Hz by dou h square. Okay, where this v square is equal to 1 by mu naught epsilon naught. Okay, I've got it here, derived it here dimensionally, right? So therefore in place of 1 by mu naught epsilon naught, now when you are replacing electric field by magnetic field, in place of 1 by mu naught epsilon naught, write it as v square dou square Hz. So again in place of Ey, replace it by Hz, okay, divided by dou x square. Okay, so this is the equation, wave equation in terms of h. Okay, similarly again wave equation in terms of E, how we can write? Dou square Ey by dou t square is equal to v square dou square Ey by dou x square. Okay, so this is the simplified form for wave equation in terms of E. Okay, where this v square is equal to 1 by mu naught epsilon naught. Okay, and if we solve this v square, the standard value of velocity of propagation of light is 3 into 10 power 8 meter per second. This which you might be heard before. Okay, so these are the two wave equations which you have got in terms of E, sorry, in terms of electric field as well as in terms of magnetic field, whenever we have any direction of propagation mentioned. Okay, in free space, these and all are things in free space, not in a particular medium, in free space. Okay, so that's all. So here one more derivation we are going to see, that is intrinsic impedance, that is the relationship between this Ey and Hz in free space. Okay, what is the relationship and what are the expressions which you are going to get? So now let's see that as well. So this is the next concept, that is intrinsic impedance of free space. Okay, so again same thing, consider Maxwell's equation from Faraday's law which we have obtained, that is del cross E is equal to minus dou B by dou T is equal to, again B is equal to mu times H, so that's why minus mu naught into dou H by dou T. So now for a uniform plane wave with the electric field E in y direction and H in z direction, and let x be the direction of propagation which we have taken for our uniform plane wave, while we are defining only we have taken it, that is E in y direction, H in z direction, and x be the direction of propagation. So what we can conclude is Ex is equal to Ez is equal to Hx is equal to Hy is equal to 0, right? We have already discussed that. So now what we can do is del cross E, again take the determinant and write it like this, is equal to mu naught into dou Hz, because we are taking H in z direction, again we have to write dou Hz by dou T into Az vector. Okay, and again while simplifying this determinant we are getting dou Ey by dou x into Az divided by minus is equal to minus mu naught dou Hz by dou T into Az, so we can cancel this Az. So dou Ey by dou x is equal to minus mu naught dou Hz by dou T. Okay, this equation whatever we got, name it as equation 1. So now what we can do is, this Ey and Hz components are there, right? In order to find the relationship between them, we can replace this Ey and Hz by E naught into e to the power j into omega t minus beta x, okay, and hz is equal to h naught into e to the power j into omega t minus beta x, okay. In place of ey and hz, replace it by these two terms and name this as equation 2 and equation 3. Now substitute these two equations, equation 2 and 3, in equation 1 in this equation, that is dou by dou x of, in place of ey, write e naught e to the power j omega t plus minus beta x is equal to minus mu naught into dou by dou t of hz, in place of hz write h naught e to the power j omega t minus beta x. So now what we can do is we need to take the partial derivation on both sides, that is dou by dou x, derivative of this equation with respect to x. So that's why what it would be happening is, this is constant, now this we need to be writing as it is, then e to the power j omega t minus beta x, its derivative is this term only, so this term again write it as it is, and now dou by dou x with respect to x, so now what, this term would be equal to 0, okay, omega t would be 0, and beta x, so coefficient of x is minus beta, and we have one j outside, so if we multiply j and beta we are getting minus j beta, right, that you write it outside, minus j beta, that is minus j beta into epsilon naught e to the power j omega t minus beta x is equal to, again minus mu naught, write it here as it is, then dou by dou t of this term. So now we need to deriving with respect to t, that is this term, again this h naught is constant, keep it outside, and this the derivative of this term is this term itself, and again with respect to t, so this term would be 0, and we have omega t, coefficient of t is omega, and we have here multiply j, so j into omega is j omega, and here we have one minus sign outside, so that's why minus j omega, okay. So that's why minus j beta and minus j omega, those two are the complex terms, so we can cancel them out, okay. That is minus j here and minus j here, we can cancel it out. So now what we are left with, beta into e naught e to the power j omega t minus beta x, and in this side we have omega into mu naught h naught into e to the power j into omega t minus beta x, okay. So if we see here h naught and e naught, now we can replace this again by this term only, that is ey and hz in place of these two terms. So now our equation is beta into ey is equal to omega mu naught into hz. So ey by hz, bring it to one side since we are finding the relationship between these two things. So that's why ey by hz is equal to omega mu naught by beta, okay, where this ey by hz, now it would be equal to c into mu naught. So now what is this c here which we've got, that we can write it as omega by beta, okay, omega by beta equal to c, and this value of c is called as the velocity of propagation of light, okay, velocity of light propagation, and its formula is given as c is equal to omega by beta. From this derivation we have got this expression as well, that is c is equal to omega by beta, you can note it down. So therefore what we are getting, in place of omega by beta replace it by c, so ey by hz is equal to c into mu naught, okay. So this is the relationship between ey and hz, okay. If you want you can stop it here only, but if you want to find the value, fixed value, okay, what we can do is we can further derive this equation, that is what we have got, ey by hz is equal to c into mu naught. So now what we can do is, this c is the velocity of propagation of light, right, but in free space. So now this is in free space, okay. In free space, if we consider the same equation, ey by hz is equal to c into mu naught, but in free space we have the relation of c, that is c square is equal to 1 by mu naught epsilon naught, right. So therefore c is equal to 1 by square root of mu naught epsilon naught, right, in free space, okay. Velocity of light has a standard value of 3 into 10 power 8 seconds. So now in free space what we can do is replace this c by 1 by square root of mu naught epsilon naught into mu naught. So now in order to cancel this mu naught in the denominator, we know that mu naught is equal to square root of mu naught square, so that is square root of mu naught into square root of mu naught, so we can cancel square root of mu naught here. So ey by hz is equal to square root of mu naught by epsilon naught. So now after substituting mu naught and epsilon naught, that is fixed value of mu naught epsilon naught, that is 4 pi into 10 power minus 7, and epsilon naught is 8.852 into 10 power 8.854 into 10 power minus 12. If we substitute these two values in this equation, our final value of intrinsic impedance in free space, we are getting it as Ey by Hz is equal to 376.7 ohms. Okay, since it is impedance, its SI unit of impedance is ohms. So this was the whole derivation of intrinsic impedance, that is Ey by Hz, relationship between Ey by Hz in free space. Okay, so this is the expression, real expression in medium. Okay, using this same expression in free space, by considering the value of C as 1 by square root of mu naught epsilon naught, we can find the fixed value of intrinsic impedance, that is 376.7 ohms. Okay, so this value you should not be forgetting. This is a fixed value, okay, for intrinsic impedance in free space using the uniform plane wave and velocity of light propagation. So this is the fixed value of intrinsic impedance. You should not be forgetting, that is 376.7 ohms. Okay, so this was all about the whole concept of uniform plane wave equation, wave propagation. Okay, so that's all for this session. Hope you liked this session and hope you understood some of the concepts and its derivation, because this derivation is very important. In this derivation only they would be asking multiple type of questions with some twisted elements. So I've explained this in detail. So please like, share, subscribe and comment down your opinion about how you understood this concept. And please share it with your closest friends, neighbors or anybody. Okay, please support our channel to be growing very faster, because we provide natural content to you all and very detailed explanation we provide. Many other channels are not providing it. We are providing it to you all. So that's why please stick to this channel. Also you can refer our playlists. It might be appearing on the right of your screen now. So please refer that as well and comment down your opinions. Okay, that's all. Thank you.